We'll now move into micronutrients, where we'll cover some vitamins, minerals, and in a later lecture, we will cover phytonutrients. So it can often be confusing when trying to understand what the recommendations are for consuming vitamins. There are a few terms that you need to be familiar with. The first is the RDA, the recommended dietary allowance. This is the average daily intake level that can meet the requirements of nearly all healthy individuals in a group. And the way it works is you find what nutrient amount is necessary for a large group of people. You end up with a bell-shaped curve, and based on the mean and standard deviation, you can approximate what 97 to 98% of a population would require. Adequate intake is used if we've not yet determined the mean and the standard deviation, but there is observational data that allows for an approximation of what the requirements might be for most people. So it's the next best thing to an RDA. And then we have the tolerable upper intake level, which is self-explanatory. It's the highest amount of a nutrient that you can safely consume, and if you go above this amount, then you're at risk for adverse effects. And the estimated average requirement describes the amount of a nutrient necessary to meet half of the group's requirements. In blue, you can see that the RDA equals the EAR plus 2 standard deviations. And for those of you familiar with statistics, think about a normally distributed data set. The mean, which is at the peak of the bell-shaped curve, that's the EAR. And then 2 standard deviations to the right of it, that would cover 97 to 98% of the people in the data set. And daily intake needs are much smaller than macronutrients. We might just require a microgram or 2. And these are also not energy yielding, although they often assist in metabolic processes used to create energy. Without vitamins, many processes would slow down due to inefficiency, and we'd suffer from a particular condition. In fact, these conditions like rickets and scurvy and beriberi are how we know about vitamins. For example, our seafaring ancestors suffered from potentially fatal ailments that inflicted lots of achy pain. That was called scurvy. In 1747, James Lind of the British Navy proved that eating lemons and oranges cured the disease, and once the substance was isolated, it became known as vitamin C. So we can differentiate these vitamins and how they are transported. Fat-soluble vitamins include A, D, E, and K, and these are absorbed and stored through fat. Water-soluble vitamins, on the other hand, include B and C, and if we consume too many of these, we excrete them through the kidney. But fat-soluble vitamins stay in fat cells, and high intake levels can cause toxicity. You don't really see toxicity in these water-soluble vitamins. Also, take a look at the rates of absorption. About 40 to 90% of fat-soluble vitamins are absorbed, about 50 to 90% of water-soluble vitamins. That's a big range there, and many factors play a role into the rates of absorption. And one is food pairing. If you want to maximize the absorption of a fat-soluble vitamin, say K, in a salad, you'll need to take in fat along with it. So include an avocado, olives, or oil-based dressing on your salad in order to maximize that fat-soluble vitamin absorption. So what makes a vitamin a vitamin? Well, to be classified a vitamin, the body must be unable to synthesize enough of it to maintain health. And number 2, the absence of the compound for the diet for a prolonged period of time will produce these predictable deficiency symptoms that will be alleviated when the compound is reintroduced. So while vitamins are typically essential, meaning that we need to eat them, there are a few instances where we can synthesize them ourselves. For example, we've heard of getting some sunlight to make vitamin D. The idea here, though, is that we can't make enough vitamin D to get us by, as part 1 of our classification says. Most Americans take in adequate amounts of vitamin A, but globally, 1 in 3 school-age children, preschool-age children, and 1 in 6 pregnant women are deficient due to inadequate dietary intake. And supplementation is highly effective with this and is being introduced to countries where this is a major concern. It's especially important for supporting healthy eyesight, vitamin A is, and also a healthy immune system. And deficiency in vitamin A, as seen in children across the developing world, can lead to blindness and infections as well. And then we have vitamin D, which promotes the body's absorption of calcium and phosphorus. Now, extreme or prolonged lack of vitamin D can make it very difficult to maintain proper calcium and phosphorus levels in the bones, and that can end up causing rickets. And you can see how rickets is characterized by bow legs or knock knees. In the US and Canada, nutritional rickets was all but eliminated by vitamin D fortified foods and drinks, but it does exist in more underdeveloped third world countries across the world. Vitamin E is best known for its antioxidant capacities. It was originally discovered as a substance in vegetable oils that was necessary for reproduction in rats, and it turned out humans needed it too. Virtually every tissue has some vitamin E in it, and it provides protections within every single cell membrane, largely against oxidative stress. Then we have vitamin K. Now the K stands for coagulation, at least the Danish spelling of it. It's essential for blood clotting, and without it, we'd bleed to death. Our bones also rely on vitamin K to synthesize the bone protein osteocalcin. As with these other fat-soluble vitamins, the absorption rates depends on its co-consumption and absorption with fat. Contrary to the original belief of early scientists who believed it was a single compound, vitamin B is made up of 8 vitamins. And these act primarily as coenzymes. Your book does a good job explaining the idea of a coenzyme. It says that they're keys that unlock the actions of enzymes. And if you had an appointment in 15 minutes that was 10 miles away, you'd be too late if you walked. However, you could drive your car, but you don't have your key. Now find your key, turn on your car, and drive to your destination. In this example, the key is the coenzyme, the car is the enzyme, and the destination, the cellular process. And the point is that coenzymes make a process just more efficient. It might happen without it, but it would take a very long time, and it would be very inefficient to do so. Vitamin B1 thiamine acts to assist in carbohydrate metabolism and maintain neural health as well. It's in the bran of grains, and that's a part that is stripped during the processing to produce white breads and rices. And when white rice was introduced to groups in Southeast Asia, they had profound muscle weakness and nerve destruction, leaving them to say in their language, berry, berry, or I can't, I can't. And this led to the recognition of thiamine as a vitamin when it was found that if it was reintroduced, that these individuals were cured. And it's used to enrich and fortify processed foods today. Once we take that bran out, we can enrich it by sending some of that vitamin B1 and others back in. It's still better just to have the whole grains, though. That's always a better option. Riboflavin is involved in many important reduction oxidation reactions, and its deficiency is relatively rare. Then we have niacin, which is thought to participate in over 200 metabolic pathways. Very important. Your body can make it from the amino acid tryptophan, and it's in meat, so deficiency also is pretty rare with it. Pantothenic acid, it's also involved in metabolic processes, as many of these B vitamins are. This one typically in fat metabolism. It too is rarely deficient. And B6 is a coenzyme that supports white blood cell synthesis and also red blood cell synthesis, along with folate and B12. B6 reduces the levels of the amino acid homocysteine, which is emerging as a major marker of cardiovascular disease. Many scientists believe folate deficiency is the most prevalent of all the vitamin deficiencies. It's especially important for females of childbearing age to consume it because it's essential for proper neural tube development, and that's what turns into the fetus's brain and spinal cord. And defects can occur within the first 30 days after conception. And that's a time when mama might not know that she's actually pregnant. So the biggest take-home point is that women should be taking in lots of folate throughout their childbearing years. It's another great reason to eat your green leafy vegetables. That's the best way to get it without taking in enriched versions of folate. Vitamin B12 is essential. Without it, all of those folate functions are blocked. And we need about 2.4 micrograms per day, although newer recommendations say that we might need 4 micrograms. Those eating vegan diets should supplement vitamin B12. They might get some from fortified nutritional yeast, which is present in a lot of vegan cheese recipes, but that would take about 3 tablespoons per day. Without vitamin B12, you might not see symptoms occur for a while. We can store enough in the liver to last us about 2 years, and deficiency symptoms might not appear for up to 12 years. Researchers estimate 3.2 to 12% of older adults are deficient, and a condition known as pernicious anemia is a major cause of its deficiency because it can destroy certain cells of the stomach, which B12 absorption depends on. In the 1940s, the US government mandated that bread and cereal products made from refined grains needed to be enriched with vitamin B, E, and minerals like iron, magnesium, and zinc. And that's because the refining process strips that bran and germ from a grain, and with it, these healthful micronutrients go. The process of returning these nutrients is known as enrichment. Now, fortification is something different. Here, companies are adding extra nutrients to a food where they wouldn't be found naturally in consistently significant amounts. Think about iodized table salt. That would be fortified because you wouldn't typically find so much iodine in salt. This has been particularly helpful in the case of folic acid. So prior to fortification, deficiency was 10 to 12% in women of childbearing age, but after fortification, folate deficiency dropped to less than 1% in this population. We've talked about how vitamin C was found. Believe it or not, most animals can make it themselves, but we can't. But what does it do? It's important in many reactions, but its claim to fame is its antioxidant properties. Eating vitamin C can be helpful also for bone health and for collagen production, so extra consumption after an injury or surgery can be helpful. And as you can see from the dietary sources list, it comes mainly from the produce aisle. Here are some tips to maximize the vitamin content in produce. You'll want to keep them cool and moisture-proof airtight containers. Avoid trimming or peeling too much of it, and cook just a little bit. Avoid adding baking soda. Don't store them for too long, otherwise you'll see a degradation in that vitamin content.